Okay. Today we are going to be working on algebraic proofs. So all a proof is a argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. And you've already used proofs before because of what we did yesterday. You've solved an equation. All you have to do is add some justification to the right-hand side. So that's what we're going to work on today, our proof. Okay, so now we have our properties. These are what you're going to use in the right-hand column to justify what you're doing. So these first four you used yesterday because we added, subtracted, multiplied, and divided yesterday. So, and these have to happen on both sides of the equation. So all four of these must happen on both sides. If you aren't adding, subtracting, multiplying, or dividing on both sides of your equation, you're just simplifying. So first off, we've got addition. Our shorthand is add prop of equal. And it says that if A equals B, then A plus C equals B plus C. Then we have the substitution, or the subtraction property of equality. So SUBT, make sure you have that T, otherwise you're not going to get that credit. Property of equality. So if A equals B again, then A minus C equals B minus C. Then we have the multiplication property of equality. Okay, and our abbreviation is MULT, prop of equal sign. And again, if A equals B, then A times C equals B times C. And the division property of equality. Again, if A equals B, but this time we've got to add a little bit more because we're dividing by another number. And it's that C can't equal 0 because in this class we do not divide by 0. So if A equals B and C does not equal 0, so make sure you have that line through the equal sign, then A divided by C equals B divided by C. Make sure you're taking notes. If you need to pause this at any time because I'm going a little too fast, go ahead and pause the video so you can take your notes. Because if you don't take notes on this part and throughout, then it's going to be really obvious on the assignment that you didn't take notes, because those people who don't take notes on today's generally do about 15 to 30 points less than those that do take notes and refer back to them. So make sure you're taking notes, make sure you're using your notes on your assignment. Okay, then those next three I'm going to skip over for the second because those are the three that you haven't seen before. And we're going to go down to substitution property of equality. And our abbreviation is SUBS. Make sure you've got that S at the end, because if you don't have that S at the end, you're not going to get credit. So I know you've seen this before, We didn't talk about it yesterday, but it's the if A equals B, then A can replace B in an expression. So that means that if you know A equals B and A equals 3, then you also know that B equals 3. And that means that B in your expression can be replaced with 3, and you can add, subtract, multiply, or divide to get whatever your answer is. And then the distributive property. So shorthand DIST, prop of equal sign. We used this yesterday. It's the one with parentheses. So if you have A, open parentheses, B plus C, closed parentheses, then when you distribute, meaning you multiply that A through the parentheses, you have A times B plus A times C. Okay, now for this last set, reflexive, symmetric, and transitive property of equality. So these are the three you haven't seen before, and notice that we have reflexive, symmetric, and then transitive, R, S, and T. So they're in alphabetical order, and what I really want you to notice is the number of signs, equal signs, that are being used in each. So for the reflexive property of equality, shorthand REFL, prop of equal sign, make sure you have that equal sign. Is just A equals A. So what is on the one side is the exact same thing that is on the other side. Completely the same. Notice there is one equal sign in that. Then we have the symmetric property, shorthand SYM, property of equality. Again, make sure you have that equal sign. Then it's if A equals B, then B equals A. So if A equals B, then B equals A. Notice that there are two equal signs on that. Notice that A and B are just flipped in position. They are not the exact same thing. They have flipped position. This is what a lot of y'all like to do at the end of your solving of your equation if your variable is on the right-hand side, because most of your algebra teachers said that your variable had to be on your left-hand side. I'm not as worried about that because that's an extra step for me when I'm having to prove. So if you like flipping your variable to the left-hand side at the end, you got an extra step. It's the symmetric property of equality. And then we have the transitive property of equality. TRANS, prop of equal sign. And this says if A equals B and B equals C, then A equals C. Notice how both A and C both equal B in the beginning. Because that happens, we can get rid of B, it's the middleman, and just go to A equals C. It's kind of like substitution, but you actually have a bit more information. So on this one, there are 3 equal signs. So reflexive has 1 equal sign, symmetric property has 2 equal signs, transitive property has 3 equal signs. Again, if you need to pause at this point because you aren't caught up with me taking notes, go ahead and pause until you have completed this chart. Next up, if you start with a valid or true statement and each logical step is valid or true, then your conclusion is also valid or true. So make sure that everything you're doing is correct, and then your conclusion will also be correct. So an important part of writing a proof is giving justification. And you have to give justification for every step. Justification can be the properties that we just discussed, postulates, which we'll talk about one briefly today and then go into it later on in the week. Definitions, which we won't discuss about any of those today, but again, we'll discuss a number of definitions more later in the week, and pieces of given information. So our next example, we want to solve the equation -5 equals 3n plus 1. Write a justification for each step. So our first step is to rewrite that equation. -5 equals 3n plus 1, because it asked us to solve that equation. And we can rewrite that equation because it was given to us in the problem. Anytime you have something that was directly given to you in the problem, all you have to do is write down given. After that, we're going to solve this like we normally would. So we have -5 equals 3n plus 1. We're going to move that -1 to the other side, or that +1 to the other side by subtracting. And we end up with -6 equals 3m. And because we subtracted, that is our justification. It's the subtraction property of equality. And yes, you can use the shorthand here. I'm not going to because it confuses some people. So, just so you know. And again, we got that subtraction because that is what we did to get to that step. So right now we have -6 equals 3n. What would we do next to solve? We would divide by 3 on both sides to get a -2 equals n. And again, what we did right there is what goes for our justification. We divided, so that's the division property of equality. Now, you could stop at that point, but if there is an extra line on your paper and you haven't filled it in, you need to do what we're going to do next. You need to flip. So it's n equals -2. And what property would we say that was when we flipped them? And it's the symmetric property of equality. So again, you only need to do that step when you have an extra line on your assignment. When you're working your proofs, everything that I wrote in black is what you have to write. The stuff that I wrote in red, your work. You do not have to show that part of it when you are filling in your proofs unless it helps you to solve the proof and to solve the equation. Next up, right, what is the temperature in degrees Celsius C when it is 86 degrees Fahrenheit? Solve the equation C equals 5/9 times F minus 32 for C and justify each step. So what are we going to write down first? We're going to write down that equation. So we have C equals 5/9 F minus 32. And why can we write that down? Because it was given to us. Now, what do you want to do next? We are not going to distribute. Why are we not going to distribute? What did it ask us to solve for? It asked us to solve for C. Hey, our equation is already solved for C. So we're not going to rearrange this. What other piece of important information have we not used yet? That 86 degrees Fahrenheit. So where does that go in our equation? It goes in for F. So we have C equals 5/9 86 minus 32. So notice that we changed F to 86. What's that called when you put something in for something else? Substitution. Property of equality. Okay, now what are we going to do? We are still not going to distribute. Why are we not going to distribute? Because we have two numbers inside the parentheses, and we do parentheses first in our order of operations. So what is 86 minus 32? It is 54. Now, did we subtract on both sides of that equation? No, we did not. So because we did not subtract on both sides of that equation, we are not going to put down subtraction, because we only put down subtraction when we subtract on both sides of the equation. Just same for addition, multiplication, and division. You have to do that on both sides of the equation. So because we did not subtract on both sides of the equation, we are going to put down simplify. Okay, now what's our next step? We are still not distributing, because that's out of parentheses. There's only one thing in that parentheses. That's multiplication. So that's what we're going to do here. We're going to multiply that 5/9 times that 54. But are we multiplying on both sides? No, we are not. So we are not going to write down multiplication over here. We are going to write down simplify. And what is 5/9 times 54? It is 30. Okay, and we have solved for C, so that is the end of that proof. Our next example, we want to solve for x and write our justification for each step. Now, this proof has already been started for you, and it says that Km equals KL plus Lm because of the segment addition postulate. I want you to put a star on your paper and right next to this picture, because anytime you see a picture like this today, that first justification is going to be segment addition postulate every time. Just like the second justification is going to be substitution today. We will talk more about the segment addition postulate in a couple of days when we talk more about segments. But right now, just know that this is segment Km, and that's the 5x minus 4, and we substituted for it. KL is this, and we substituted that x plus 3 for it, and Lm is right here, and we substituted that 2x minus 1 for that Lm. So we have 5x minus 4 equals x plus 3 plus 2x minus 1 right now. What would we do next? We would combine our like terms. So we have no like terms on the left-hand side, so we're just going to write that down, 5x minus 4. But we have several like terms on the right-hand side. So we have x and a positive 2x, and that would get us x plus 2x, which is 3x. And we also have a positive 3 and a negative 1. So positive 3 minus 1 is a positive 2. Now, we combined our like terms. All of that happened on one side. So we added or subtracted on one side of the equal sign. What do we call that when it only happens on one side? That is simplify. Okay, next up, we have 5x minus 4 equals 3x plus 2. We deal with our variables first. So which one's larger, the 5x or the 3x? 5x. So that means we're going to move that 3x. And we're going to subtract that 3x from both sides. So we have 2x minus 4 equals 2. And we subtracted. So again, our justification is subtraction. Again, the important part is what's written in black, not what's written in red. Red is the work. The black is the step. Okay, so we have 2x minus 4 equals 2. What are we going to do now? We're going to add 4 to both sides. So we have 2x equals 6, and we added. So our justification is addition, property of equality. Again, the red is the work, but black is my step. Then next up we have 2x equals 6, and we're going to divide by that 2. And we have x equals 3. And since we divided by 2, our justification is division property. So again, the red is my work, the black is my actual step. It's what goes on that line. And remember that anytime you have a picture like the one we have here, that you need to refer back to this problem, and the first justification is going to be segment addition postulate. The second justification is going to be substitution, and you will need to substitute. Last up, we have the reflexive, symmetric, and transitive properties of congruence. So, does anybody remember what congruence means? Same size and shape. And remember that your symbol for congruence is an equal sign with a squiggly line on top. So, reflexive, symmetric, and transitive properties of congruence. Same thing as your properties of equality, but we have congruent sign instead of an equal sign. So when you shorthand this, make sure that you put a congruent sign afterwards instead of an equal sign. So our first one here, for reflexive is that segment AB is congruent to segment AB. You could also have segment AB being congruent to segment BA. I want you to make sure that you write that down. I know it might be a little confusing considering what we said about reflexive property being the exact same on both sides. But trust me, those are, and we'll discuss more about that tomorrow as to why segment AB is the same as segment BA. Then symmetric property, if you've got angle 1 and it's congruent to angle 2, then angle 2 is congruent to angle 1. Again, notice that there are two congruent signs on symmetric and one congruent sign on the reflexive because this is two different examples. And transitive property, if segment X, Y is congruent to segment Y, Z, and segment YZ is congruent to segment VW, then segment XY is congruent to segment VW. Okay, again, notice that there are three congruent signs and that segment YZ was the same between those two sets of segments. So that's why we put segment XY congruent to segment VW. Our last example, we want to identify the property that justifies each statement. Now this can be any property that we discussed today. Our first example, we have the measure of angle 1 equals the measure of angle 1. What would that be? Okay, it's not the symmetric property because there's only one equal sign. It's a reflexive property. Of what sign do we put? Because we have an equal sign. We write down equal sign. So we have a reflexive property of equality. Our next example, segment XY is congruent to segment VW. So segment VW is congruent to segment XY. What do we have for that one? It is the symmetric property because we only have two signs. And what sign do we put after? We put the congruent sign because that's what we have in our problem. So we have the symmetric property of congruence. Next up, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So angle 1 is congruent to angle 3. Yes, that is the transitive property of congruence. And remember, that is congruence because we have the congruent symbol.
last up, angle ABC is congruent to angle ABC. Yes, that's a reflexive property. And it's not of congruence, it's not of equality, it's of congruence, because there's a congruence sign. Again, make sure that you are using your notes to complete your assignment, because it is very obvious on today's assignment who has referred back to their notes.